previous video, we talked about the mechanism of the Sn2 reaction. Now, you know the first step and the slowest step of the Sn2 reaction, which is the rate limiting step, depends upon this step right here. We're just going to draw this step, the first step of the mechanism for this specific reaction. This is -1 charge. That hydrogen is right there. It's really kind of insignificant. The only thing that's interesting is the nucleophilic atom in its orange lone pair, because it's performing the nucleophilic attack. Now, the interesting thing here is this. Okay, this, and I'm kind of drawing it far away so you can really understand what I mean here in this step. It's really important. Okay, I'll draw that iodine. Okay, it's right there. Now, and still that's A, that's B still. Okay, now, you know, we've been talking about this for a while now, but, okay, the nucleophile is going to attack the electrophile. Or this orange lone pair is going to attack A. And of course, you know, when that happens, this is going to happen. Okay, that happens, fine. And that is considered to be, in this mechanism, step number 1. Fine, we talked about that. Okay, what's so interesting about that? Well, of course, you know, inside that beaker, this is happening. Like, it's happening all the time. I don't know, a million times, 100 times, every fraction of a second. I don't know. It happens a lot because, you know, just think of a 1 mole Avogadro's number. I mean, that's a lot of stuff. So when we put like several moles in here, because we put a lot of liters of it, and that's a lot of moles. But just think about how when this attacks this and this leaves, think what else is surrounding these two molecules. I mean, don't get me wrong, the rate is dependent upon these molecules for the product to form, but still, the rate of this is affected by the mechanism. Well, the rate of this process is still affected with what surrounds it. And what I mean is, what did we submerge this molecule in? We submerged these two molecules. We submerged there's another molecule involved with the mechanism besides these two. We submerged these two molecules in the beaker. In this molecule, acetone is a ketone. That's why it has "-one" in it. And I'm going to put up a functional group video if you want me to do that too. So, okay, let's talk about what type. Okay, well, of course, let's talk about some general chemistry concepts real quick. Now, the thing is this. When I mix these things together, I told you I mixed these things together earlier. And what I mixed these things with was this ketone, acetone, hydroxide, and I mixed it as hydroxide. I'm just going to keep it as simple as that. And this iodoethane. Now, the thing is this. Of course, you know in chemistry, when you mix things together, that's a solution. And a solution is made up of two things, a solvent and a solute. Now, I put more of this. I didn't tell you that before, but I put more of the acetone in there, the ketone. And I put less of these two in the beaker when I put these in there. That makes this the solvent, and that makes these two the solutes when I mix these two, all of these three molecules together. And this here, the solvent, that's of interest to us. We talked about the solutes. The solutes are the electrophile and the nucleophile. We talked about those. The substrate, leaving group. The iodine is leaving group. Whole thing is substrate. That's nucleophile. Carbonate is the electrophile. The oxygen is a nucleophilic atom. The whole thing is a nucleophile. The oxygen is a nucleophilic atom. The lone orange pair is what performs a nucleophilic attack. Now, we talked about all that. Now, this is what is of interest to us, this solvent. We didn't talk about the solvent. Why do we specifically put it in acetone? And don't get me wrong. Let's say in my lab, I had a couple of other choices, but I didn't have such a wide choice, but maybe I had like 10 or 12 different choices in my lab. And I picked this one. And why did I pick this one? Let's look at something interesting. Why did I pick this one versus picking... Why did I pick this one versus picking... Why did I pick acetone versus picking just good old-fashioned water? Why did I do that? Let's see. Let's put a question mark there. Question mark, water. It's this problem in the next video.